Hello students, today we are going to see the problems in reflection and refraction chapter 10 for class 10. See, first the main trick of solving a problem is understanding the problem. If you understand the problem clearly, you can easily solve the problem. First thing is you have to read the problem carefully. Find out the given data and find out the data which has to be determined. And you relate all these data and formulate and use the formula which relates all these data. And then a mere substitution and a simple mathematical manipulation is required to solve these problems. So with these useful tips, let us get into the video. Here I have solved a few NCERT exercise problems which will help you to work out any other similar problems. So let me start the video. The first problem is, it is based on converging lens. What is a converging lens? It is a convex lens. So you have to read the problem first. An object 5 cm in length is held 25 cm away from a converging lens of focal length 10 cm. Draw the ray diagram and find the position, size and the nature of the image formed. So here in the problem, it is mentioned as converging lens. So it is a convex lens. The focal length of the lens is given as 10 cm. So you have to take it as plus 10 cm. The sign convention of the data is very important in case of light problems. Next, the object height is 5 cm in length and it is kept 25 cm away from the lens. So always the object distance should be mentioned as negative sign. So object distance u is minus 25 cm and the height of the object is always positive, that is plus 5 cm. So these are the given data. So you have to determine what is the image distance and the height of the object. Using lens formula, that is 1 by f is equal to 1 by v minus 1 by u. You have to find out what is v. So a mere mathematical simplification is used. That is 1 by v is equal to 1 by f plus 1 by u. 1 by f is 1 by 10 and 1 by u is 1 by minus 25. So if you simply substitute these values, you get v is equal to plus 16.66 centimeter. And the next data to be determined is the height of the image, which can be determined using the magnification formula. Hi by h0 is equal to v by u. Hi is the image distance. Hi is the height of the image. Ho is the height of the object and v is the image distance, u is the object distance. So simply substitute the data in the given formula and find out hi, that is the height of the image, which is obtained as minus 3.3 centimeter. What does this minus sign represent? It tells us that the image formed is an inverted image. And what does this plus sign in the image distance represent? That is, the image is formed on the other side of the lens. So what do we understand by the nature of the image? The image is a real and inverted image. Let us draw the ray diagram. A convex lens has focal length on the other side of the lens. So you have to fix the object distance as minus 25 centimeter and we have obtained the image distance as plus 16.66 centimeter, and using the height of the object we have determined the height of the image as 3.3 centimeter. Next, the next problem is based on a mirror. So I'll read out the problem here. An object is placed at a distance of 10 cm from a convex mirror of focal length 15 cm. Find the position and nature of the image. So here it is said it is a mirror. The focal length of the convex mirror is represented as plus 15 centimeter, and the object is placed at a distance of 10 centimeter. So always you should take object distance as minus 10 centimeter. In all cases, whether it is lens or mirror, the object distance should be taken as negative. And here you have to determine the image distance and the nature of the image. And using the mirror formula, we know that 1 by f is equal to 1 by v plus 1 by u. Here 1 by v is equal to 1 by f minus 1 by u. Again substitute the given values in the formula and do a simple mathematical calculation, and so we obtain v is equal to 6 centimeter. And again using the magnification formula, you can find out how much is the image magnified. So you get 0.6. The magnification m is equal to 0.6, 0.6. What do you understand by this? It means that the image formed is smaller than the object. So this is the ray diagram for the convex mirror. And always you know that any object which is placed in front of a convex mirror will be seen as a smaller object. That is, the image will always be smaller than the object, and it can be seen only on the mirror. You don't want a screen to obtain the image, because all the images formed in a convex mirror are always virtual and erect images. And this is the property which makes the convex mirror to be used as a rear view mirror in the vehicles. So this is the ray diagram for the given problem. The next problem is an object of size 7 cm is placed at 27 cm in front of a concave mirror of focal length 18 cm. At what distance from the mirror should a screen be placed so that a sharp focused image can be obtained? Find the size and the nature of the image. So here again find out the given data for the given concave mirror. So here the object is concave mirror. The object distance is 27 centimeter. So we represent it as minus 27 centimeter. And the object height is given as 7 centimeter. And the focal length of a concave mirror should be taken as minus 18 centimeter. So here is the difference. So in a concave lens, you have focal length minus, and in a concave mirror also focal length is minus. And convex mirror and convex lens focal length will be taken as plus. So that is the difference. And here in the question it is asked that at what distance from the mirror should a screen be placed? A screen is used to capture the image. So when you place a screen, and if you measure the distance between the mirror and the screen, it is the image distance. It is called as the image distance. The distance between the mirror and the screen is called as the image distance. So we have to determine what is the image distance and size of the image and nature of the image. So here again you have to use the mirror formula. 1 by f is equal to 1 by v minus 1 by u. 1 by f is equal to 1 by v plus 1 by u, and 1 by v is equal to 1 by f minus 1 by u. So from that, by substituting the given data, we get v is equal to minus 54. Now it is understood that the screen should be placed at a distance of 54 centimeter in front of the given mirror. And using the magnification formula, we get the magnification as minus 2. What does this minus 2 indicate? Minus 2 indicates that the image formed is a real image. And the other one asked in the problem is the height of the image or the size of the image, which again can be calculated using the magnification formula, and the height of the image is minus 14 centimeter. So the value of the height of the image is negative. So it indicates that the image is inverted. So these are the three types of problems given in your NCERT textbook. Based on this, you can solve any other mirror and lens problems. Next problem is the one half of a convex lens is covered with a black paper. Will this lens produce a complete image of the object? Yes, it will produce a complete image of the object. You can experimentally verify this by observing an image of a distant object like a tree or a sun. You focus the tree or a sun using a lens, convex lens, and you can place a screen on the other side and you can still see an image formed on the screen. Only thing is, the brightness of the image will be reduced because the intensity of the light falling on the lens will be reduced to half. So you will get a blurred or a little brighter image other than what we get regularly. So here is the ray diagram for the given case. So if you cover the half of the lens with a black paper and you draw the ray diagram to obtain an image. So now from AB object we have taken two rays and we find the refracted rays. They meet at a point A dash B dash. So here also we get the complete image, full length of the image of the object. So we understand that even if the half of the lens is covered with a black paper, you can obtain the complete image. Only thing is, intensity of light will be reduced. So the brightness will be reduced. So this is one case of using lenses or mirrors in our daily life. So this is also a type of question. It is a HOTS question. It is a type of higher order thinking level question. So you have to understand the question and try to answer the question. Hope all of you understood how to solve the problems in light reflection and refraction lesson. In the previous video, we have shown a fewer problems related to the power calculation and the relation between power and focal length, and a few problems related to radius of curvature and focal length. And in this video, you have seen some more problems in detail. So I hope all of you have understood the technique of solving problems in this lesson. Thank you for watching the video.